Hey everybody, I wanted to go over some of the answers in the Ultimate Chemical Equations Handbook. This is Chapter 5, and this is how to name coordination compounds. And so let's get started. This is exercise 5-1, and so this is number 1 of that. And so we're given a formula. and we have to make that a name. Now I do have a table. It's a little bit different than the one that's in the Ultimate Chemical Equations Handbook. It's but it still has the same information on it. Okay, and so just like any time, what you want to do is you want to take this compound and you want to split it in half. Okay, and so this is the positive side and this is the negative side. And I get it. Okay, it's not as easy as just naming sodium chloride NaCl and then we name it sodium chloride, but there are some similarities. We want to name the positive side of the compound first, and then we name the negative side. Okay, and now there are some special rules about naming the positive side of a coordination compound, and if the negative side is a coordination compound, if that has a metal in it as well, then we have to follow those rules. Okay, so let's just get started, because I think that by example we kind of see what's going on. Okay, and so here's what we're going to do. We're going to split this compound in half, and we're going to name the positive side first. Okay, when we name the positive side first, I always take and I start backwards from where I drew my line here. And so this is going to be, for number 1, this is going to be di, because that is 2. And then we're going to look for NH3 on this list. And NH3 is right there. And so that's diamine. Okay, let me make sure that it pops up there. I don't know what the deal is. Okay, so that's diamine. And now this is silver. Ag is silver. Okay, now silver is a transition metal, but silver is unique because silver, for transition metals, only will ever have one charge. Silver is always going to be Ag1+. So because silver is always 1+, we don't have to write its charge in parentheses. So this is the diamine silver ion. So we've named that part of it. Now what about this? Okay. Well, that is the anion half of this, the negative half, and it's not a metal. It's not some sort of coordination compound. It's not some sort of coordination ion. It's just chlorine. So just like this, when chlorine is alone, what is it here? Well, same thing. So it's chloride. Okay, so this is diamine silver chloride. Okay, so now number 2. Okay, and again, we need to get practiced at where to split this to know where the positive and the negative is. And so I'm always looking for these square brackets. That usually separates those ions. Okay, and so we have this half and this half, but we always want to name the positive side first. Okay, again, going back to our sodium chloride, we name the sodium first, and then the chloride, we name the positive side first. And the positive thing is always listed first. Okay, so this is NH43. Now notice that's not a metal. Okay, there's no metal in there. It's not coordinated like number 1 was, okay, or like number 5 is. And so we're just going to figure out what that name is. Now that name goes back to where we, from just naming kind of standard ionic compounds, that's the ammonium ion, okay? And so that's ammonium, and we don't put 3 in there, okay? We don't put tri because these are all ionic compounds, coordination compounds, have 2 ions, so we don't have to worry about that. And now when we come and name this half of it, this is the side with the metal, so we're going to name it backwards. So we're going to start here, and we're going to go hexa That's the number prefix, and then we're going to find SCN. Oh, look at that. That's thiocyanado. Okay, that's so weird, but that's the way it is. And now this is Fe, that's iron. Okay, now this, we kept it as silver, but when the metal is part of the negative charge, okay, when the metal is part of the negative charge side of the thing, then we have to make sure we use the Latin name. So iron, the Latin name is ferrum, but then we change it to ferrate. Okay, ferrate. And now, because this is a transition metal, the other thing applies that we've learned way back when, was that we need to include the charge on this. Okay, so this is where kind of figuring out charges can get interesting. So this is, the charge on an ammonium ion is plus. So there's 3. I'm going to do this in green because maybe that'll help set it apart. Okay, so this is 3 plus total on this side because there's 1 plus for each ammonium and there's 3 of them. Okay, thiocyanado is here a 1 minus charge. You can just barely see that. The book, the copy, whatever you're using from the actual Ultimate Chemical Equations Handbook, that's a lot clearer to see. Okay, but there's that. That's a negative. And how many of them do we have? We have 6 of them. So that's 6 minus. So what, in order for these things to add up to 0, because it's a neutral element, this has to be 3 plus 3 plus 3 plus 6 minus. So this is going to be ammonium hexathiocyanado ferrate 3. Yeah, it sounds weird, but that's what it is. Okay, so we're moving right along. I'm going to make a little more space. And my suggestion is always to pause the video, try it, and then go through excuse me, and go through it, see if you get the right answer. Okay, so now, again, we're going to split that in half. Okay, just like sodium chloride, this half over here is sodium, and that's it. No sodiumate, no no Latin, because the positive side, nothing changes about the metals when it's on the cation side or the positive side. And now we have the negative side here. Okay, so again, when we have these coordination ions, okay, we want to start backwards. So we're going to start here with tetra. Okay, tetra, and then Cn. If we look at Cn, that's cyanide. That's what we know is cyanide, but Cn is cyano. Now tetracyano. Okay, cyano, and now we're going to use nickel. Okay, the Ni is nickel, so that's tetracyano nickelate, because it's the negative side. This ion is on the negative side, so on the anion side. So because it's on the anion side, we make it the nickel 8, and now it's a transition metal, so we need its charge in parentheses. Sodium, I'll do it in green to separate it. So sodium is always 1 plus. Okay, so there's 2 of them, so that's 2 plus. Cyano is 1 minus. There's 4 of them, so that's a total of 4 plus. Or so, sorry, 4 minus. So that means that nickel must be 2 plus in order to do that, in order to get that right. Okay, let me move this down slightly. Okay, so now number 4. Now this is just an ion. Okay, there's not 2 parts of it. Every other element, every other compound here, you can see the 2 parts. We've separated in 2 parts. How do I know this is an ion? Because there's an overall charge on this thing. Okay, so let's spend a little bit of time. Ooh, I just erased the answer there. Spend a little time naming this ion. And so again, since it's just an ion, we're going to start by naming this backwards. Okay, we're going to start here. Now this is where it gets, again, kind of slightly special rules. Whenever you have a complex ligand, one of these things attached, Okay, then we don't use the standard abbreviation or the standard number prefix. Okay, and so that standard number for 3 would be tri. Okay, so you put tri and then OX over here, you're going to find out is oxalato, okay, which is here. It's abbreviated OX. So that way we don't have to write out C2O4 2 minus. Okay. But it's a complex ion. It's what we call bidentate. It can attach in 2 places. Okay. All of that to say is oxalato is complex. So instead of using tri, we use this fancy thing called, we say tris. Okay. And so it's tris oxalato. Let me make sure. Yeah, oxalato. Okay, so it's tris oxalato, and then iron. Now this is a negative charge. Negative charge means that it's that we have to use the Latin for that. Okay, so that's going to be ferrate again. Okay, and now it's a transition metal, so we need to indicate its charge. Well, oxalato is a 2 minus, so 3 times 2 minus makes that overall charge a 6 minus, and we want the total charge to be 3 minus, so this must be 3 plus. So this is going to be tris oxalato ferrate 3. Okay. Now the last one here. Okay. Now this one is good because we can split it in 2. So we're going to start. We're going to go backwards. The prefix for 6 is hexa. Okay, so that's hexaamine, because amine. Amine. Cobalt. Now, if it's a transition metal, we need to figure out cobalt's charge. Okay, except for silver. Silver, zinc, and cadmium. Those are the 3 exceptions. Just like this one up here, silver didn't have, it's always +1. Okay, so how do we figure out its charge? Well, I'll do it in green. Okay, well, this is 0. There's 6 of them, so that's 6 and 0. And so bromide is -1. There's 2 of them, so this is 2 minus. So what plus 2 minus is going to give us 0? 2 plus, right? Okay, so this is cobalt 2. And now this side, there's no metal. So because there's no metal, that means that this is just like it would be if it were in a kind of a traditional ionic compound. And so this is bromide. And that's it. Okay, so that explains kind of in detail how to go over questions 1 through 5 in the problem set 5-1 in Ultimate Chemical Equations Handbook.